All right, so in section 5.2, we're skipping 5.3. What we did was we looked at how to find theoretical probabilities. So remember, when finding theoretical probabilities, we actually don't run a simulation or actually observe anything. We just use pure numbers and logic. In this section 5.2, we're going to be looking at finding empirical probabilities, which is where you actually do run an experiment or a simulation of an experiment and then report your findings. So what we do is that we collect data and draw the probabilities from that data. So, for example, suppose that theoretically tossing a coin and having it come up heads is 50%. If we do the simulation 10 times and find that it comes up heads 3 times, that would be the empirical probability. So the empirical probability would be 30%, while the theoretical is 50%. So one of the questions that we're going to be asking in future chapters is, does this mean that the coin is unfair? So what happens to the probability of getting of getting heads if we flip the coin an infinite amount of times? Well, the more you do it, the more it should match up to the theoretical probability. So first, when you're trying to create a simulation to find an empirical probability, so for example, a simulation can mean that you are running a computer program over and over, like you guys have seen for physics apps, or for like if you watched a crime show and they have a criminal reconstruction. Here's one of the things that we do when we're finding an empirical probability. Is first we identify the random action and the probability of a successful outcome. After that, we determine how to simulate this random action. So are we going to roll die? Are we going to flip a coin? Are we actually going to look and record these things? We want to determine the event that we're interested in. We want to explain how we'll simulate one trial. After that, we're going to do that trial, record whether or not the event came up, and then we're going to repeat this at least 100 times. Okay, sometimes you'll have to do it more depending on the situation you're looking at, but 100 times is a good rule of thumb. After that, you're going to take the number of times that you saw the event you're interested in, divide it by the number of trials, and that's going to be your empirical probability. So, flipping a coin takes a lot more time than you'd think. So, instead of doing that, we're going to simulate it, and one of the ways we're going to do that is using a random number generator or tables. So today we would most likely use a random number generator in Excel or some other computer program. But way back in the day, before computers, they used to have these books that were just full of random numbers, no joke. So you'd open it up to a random page, read off those random numbers, and that would give you your simulation. So let's say that we want to flip 3 coins. And we want to use the random number table that I have below to simulate the action. And here what we're going to do is that we're going to let the numbers 1 through 4 be heads, and then we're going to let the numbers 5, 6, 7, 8 be tails. Okay? So the event that we're interested in is getting tails at least once. So to do this simulation, we're going to do it 10 times instead of 100, just in favor of time. And then we're going to record our data below, and we're going to start with line 3 of the random number table. So here we're going to start at line 3 of the random number table, and 1 through 4 are heads and 5 through 8 are tails. So here we are going to start looking, and I'm going to do this in a slightly different color just so it's a little bit easier for me to see. So let's see, we have 2, 6, and 4. Okay, so when I record those, I'm going to have the numbers 2, 6, and 4. So remember that numbers 1 through 4 are going to be heads, and the numbers 5 through 8 are going to be tails. So a 2 would denote heads, a 6 would denote tails, and a 4 would denote heads. So the number of tails that I see is 1, and did the event occur? So remember, I was interested in getting tails at least once, so did that event occur? Yes. All right, so we're going to keep going through these. I'll do the first couple just so we can follow along. And then I will cut the video down so you guys don't have to watch me just write down random numbers. So then the next one, we're going to have 2, 7, and 4. So 2, 7, and 4. So 2 would be considered heads. 7, that's a number from 5 through 8, so that would be considered tails. And 4 would be considered heads. So we got 1 tails. Did our event occur? Yes. All right, now notice that the next number on the random number generator is 0. But when I define my heads and tails, I said numbers 1 through 4 or 5 through 8. So what we're going to do is that we're going to skip zeros and just write down the next 3 numbers that apply. So we're going to have 6, 5, and 7. So that's going to be tails, 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 which means that we got 3 tails. Did our event occur? Yes, it did. Now we're going to look at the next 3 numbers. So remember, we didn't include 0, so we're going to skip that. So we're going to look at 2, 5, 1. So 2, 5, 1. So that would be heads, tails, heads. We got 1 tail. Did our event occur? Yes. So we're going to keep doing this until we finish 10 trials. So I'm going to go ahead and clip the video. So at the end, you'll see all of this data and you can look over it on the solutions and make sure that yours match up. All right, so I filled out the table. Now notice that when I was going through the random number generator above, anytime I ran into a 0 or a 9, I just skipped it since our variables were only defined as 1 through 4 or 5 through 8. This would come in handy if instead of looking at just heads or tails, let's say that we were looking at our friends and we only had 5 friends and we would label them 1, 2, 3, 4, 5. Then we would skip any numbers that weren't 1, 2, 3, 4, or 5. All right, so when we look at our data, here's what we saw is that the empirical data says that out of the 10 trials we did, the event that we saw, which is that we wanted to see tails at least once, we saw that 1, 2, 3, 4, 5, 6, 7, 8 times, which gives us an empirical probability of 80%. Now, the theoretical probability, remember, to find a theoretical probability, what you do is that you write out your sample space and then you look at the total sample space in the denominator and then the number of times your event occurred in the numerator. So, theoretically, here are all of our 8 options. Heads, heads, tails, heads, tails, heads, tails, heads, heads, tails, 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 heads, tails, heads, tails, heads, tails, tails. So here we have 8 different possibilities, okay, theoretically, and the number of times that we see tails at least once is 7 out of those 8. So the theoretical probability is 7 out of 8, which gives us 0.5%. So here's the deal, is that when we compare our empirical to our theoretical, they're off by a little bit. But let's think about this. We only did this trial 10 times. So the amount of times that we could have seen our event is only going to be in tens. So there could have been a 0%, 10%, 20%, etc. So we never actually hit the theoretical percentage unless we did it at least 1,000 times. However, for only doing it 10 times, 80% is relatively close to 87.5%. Now, the law of large numbers says that if we do an experiment with a random outcome many, many times, then the empirical probability is going to get closer to the true theoretical probability. So let's go ahead and look at this. Let's say that we flip a coin. We want to look at the probability that we get heads. So the theoretical probability is always going to be 0.5. It's always 50%. Now, the empirical probability, well, if you only do one trial and you get heads one time, you're going to think that the empirical probability that you get heads is 100%. Same thing if you do it twice and you get heads both times, then you're still like, oh my gosh, 100%, 100%. But now, so that was 1 out of 1, that was 2 out of 2, that was 3 out of 3. However, when you flip it the fourth time and you get tails, then you got heads 3 out of the 4 times that you flipped your coin. So now the empirical probability has dropped down to 75%. When you do it a fifth time and you get tails, that means that the empirical probability you get heads is 3 out of the 5 trials, which is now 60%. So notice that our empirical probability, as we move forward, is getting closer to that 0.5. However, on the sixth one, we have 4 heads now, so 1, 2, 3, 4 out of the 6 times that we flipped our coin, and that's going to bring our probability back up to 66%. So what we're going to see happen is as we do more trials, so 4 out of 7, that's going to give us 0.57. As we do more trials, what we're going to see happen is that we're going to have that 50% theoretical probability that we want to see. And what our probability is going to do is it's going to bounce around it, but the more trials we do, it'll eventually level out and get closer to that 50%. So I'll just go ahead and fill the rest of these in. So it would be 5 out of 8. That would give me 0.625. This would be 5 out of 9, which would give me 0.5 repeating. And finally, this would give me 6 out of 10, which would give me 60%. This is a lot of fun to do in Excel when it goes relatively quick. And that's something I like to do. And just for fun, I'm going to give you guys a real life example of something that I personally was interested in recently. So I'm currently pregnant with twins, and I found out that I'm having 2 girls. But before I found out what my baby's sexes were, I was like, well, what's the probability, theoretically, of having a boy and a girl? I kind of wanted to get it over with and have one of each, but, you know, life makes other plans. So, theoretically, I could either have a boy and a boy and a girl and a boy, or 2 girls. So, theoretically, the probability of me having one of each, well, let's see, my sample space is 4, and there's 2 events in which I have one of each. So theoretically, the probability is supposed to be 50%. Well, that's cool, but I don't know if you guys know this, biology doesn't really care about theoretical things. So the empirical probability, what that means is that when you actually look at all of the twin pregnancies that are fraternal, that means that they have 2 separate eggs and it's not just one egg that's split, that would be identical. When you look at the empirical probability for fraternal twins, what happens is that the probability for having a boy-girl pair is actually significantly less. It's actually only 30%. Now, when I read more into this, it had to do with the biology and the hormones of your body and, like, you know, maybe the babies are more viable if they have the same hormone structure. I don't know. Anyway, I thought that was very interesting, and it's one of those occurrences where maybe having a boy-girl pair of twins isn't as independent as we think. Maybe it's more dependent on body chemistry and hormones and things like that. Anyway, just thought that was fun to share. We're going to be moving into chapter 6, which is probably one of my other very, very favorite chapters. I know I say that about all of them, but yeah. All right, I'll see you guys in chapter 6.